From NASA's Jet Propulsion Laboratory, JPL, Pasadena, California, a three-dimensional look at the Earth, Stereosat. That's the story Willard Scott reporting, details coming up. This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. A satellite concept to aid scientists, geologists, and map makers is being studied at JPL. This system envisions a polar Earth-orbiting spacecraft pointing 3 cameras at the Earth, one vertical and the other 2 looking forward and rearward 25 degrees from the vertical. The system, called Stereosat, is now in the study phase. If accepted as an official program next year, it could be launched in 1983.
The concept of the Stereosat is to take successive images of the same spot on the ground as the satellite moves overhead.
That's Alan Conrad, manager of the Stereosat Development Flight Project at NASA's Jet Propulsion Laboratory.
The Stereosat Development Flight Project is an initial look at a potential evolve images of the ground that permits photogeologists to examine the ground in the third dimension, the vertical dimension, and which aids them in their search for Earth resources, that is oil and minerals, which are in a great shortage these days. And the private industry is interested in this data from the standpoint of how they might best invest their exploration dollars in the search for the oil and minerals that still exist and still have not been located. This data will permit the photogeologists to make more clear identification of the rocks in the various land masses of the Earth, and it will also allow them to understand in more detail the topography of the ground, the faulting and folding of the Earth, which allows them to put the geological story together that permits them to deduce the potential presence of the minerals or oil that they're searching for.
The 3 cameras, aligned in the orbital plane, will take pictures at 50-second intervals as they move over a point on the Earth.
The data that the Stereosat will acquire will be very complementary to the data previously acquired from the Landsat satellite series. Landsat images are taken vertically. There is very little stereoscopic imagery that's possible with the Landsat system. And so this data is quite complementary to that. The Landsat data provides information in several spectral bands, which aid the geologist in interpreting what he's seeing on his photos. Now, the images that will be prepared through Stereosat will be utilized along with the Landsat images to provide a third dimension which complements the information from the multispectral scanners and thematic mapper on the Landsat.
Conrad's group is presently developing requirements for the project, working with interested scientists such as the nonprofit GEOSat Committee.
Another source of requirements would derive from users within the federal agencies. Most prominently, we anticipate the design to be driven by the requirements of the Department of the Interior, primarily the United States Geological Survey, which is responsible for the mapping of the United States. These data will be acquired in a timely fashion during this next year so that the engineers can then move out and put together designs that are consistent with the requirements that are the products of these scientific and user groups.
This has been the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott speaking. From NASA's National Space Technology Laboratory, NSTL, based St. Louis, Mississippi, we look at the Regional Applications Office, a helping hand for southern states. That's the story Willard Scott reporting, details coming up. This is the Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Several years ago, NASA was encouraged with the National Council of State Legislators, the United States Congress, and others to increase its emphasis on the utilization of its space technology in the public sector. NSTL had already been involved in research and development of techniques and methods to utilize data acquired from the Earth Resources Satellite. So, they were a natural choice for a Regional Applications Office.
The main thrust of the Regional Applications Program is to transfer Landsat or remote sensing technology to state and local government users.
That's Roy Estes, Chief of the Regional Applications Group at NSTL.
And what does this mean in simplified terms? Simply put, it means that the techniques that have been developed through NASA's research programs should now be made available to public governing agencies at the state and local government levels on a routine basis in order that it can be put to work in managing the natural resources of this country. In order to do this, NASA chose 3 of its centers to assign this responsibility to. Ours at the National Space Technology Laboratory have been assigned 17 states, bounded on the west by New Mexico, stretching up and including Nebraska, across Missouri, Kentucky, and the Carolinas, and all the states bounding in the southeast part of that country.
NASA's Goddard Space Flight Center in Greenbelt, Maryland covers the Northeast, and NASA's Ames Research Center in California handles the western part of the United States.
The thrust of our regional programs here at the Earth Resources Laboratory is 3-pronged, really. The first being a training program. We operate at the laboratory here a continuing training program. We have professional instructors. We have a classroom set up in being, including a data processing system, where, quote, students, unquote, from all over the region assigned to us come here and receive hands-on training with the use of the computers and the data. This training program over the last year has been very successful. It's been full practically every week, and continues to have a great demand on the availability of that time.
Demonstration projects are the second major thrust of the NSTL Technology Transfer Program.
Going over this list of projects or potential activities that the state itself develops, then we in NASA, jointly with the state, identify some problems for which we could then demonstrate the utility of Landsat in helping to solve those problems. Then the third aspect of our regional program that's up front is working directly with the key universities within our assigned region. Specifically, there we're working with universities who have some interest and some basis for instructional activities in the use of remote sensing. There we contract with various universities to teach short courses for their own professors and for state agency personnel.
As a result of these activities, satellite data is gradually becoming a regular tool of state and local governments. This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott speaking. From NASA's Ames Research Center, Mountain View, California, a look at the origin of the universe using the U-2. That's the story Willard Scott reporting. Details coming up. This is The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. It is theorized that our universe was created at a specific point in time and space. Created when all of the matter that exists condensed into a large cloud of primarily hydrogen gas that exploded. That great explosion, the Big Bang, created all of the galaxies and their solar systems.
If this is a true theory, it says that you should be able, essentially, to look back in time and confirm this event.
That's Bob Cameron, Chief of the Airborne Science Office at NASA's Ames Research Center.
And it's done in a way that says that if the Big Bang theory of the origin of the universe is true, that if you look in the universe, no matter where you look, you should see a residual from that explosion, a temperature, if you will. And that temperature should be something like 3 degrees Kelvin, or 3 degrees above absolute zero, no matter where you look in the universe. And a number of experiments have been conducted in the past at various wavelengths of light or of radio frequency that tend to confirm the Big Bang theory. However, it also, the theory says, that you should, if the Big Bang were true, that you should be able to determine essentially the direction and motion, if you will, of not only our sun and our planets, but the galaxy in which we reside, the Milky Way. Should be able to determine a direction for that and its ratio or relation to the overall direction, since presumably the Big Bang, everything kind of moved out more or less uniformly. Well, that's the theory, but it's a very difficult thing to observe. One of the optimum ways that has been proposed in the past was to do this from a satellite, because you must make very, very precise measurements of time and of frequency of light, if you will.
Scientists at the University of California at Berkeley felt that it could be done using one of NASA's 2 high-flying U-2 aircraft equipped with a microwave radiometer.
In order to do this, you have to be free of any spurious signals induced by our Earth, either man-made or natural. You have to be above a goodly percent, over 99% of the water vapor in the atmosphere, and above about 85 or 90% of the total atmosphere, because the atmosphere itself emits strange radiations which are considered noise. Well, the U-2 aircraft operated here have the altitude capability. They can operate with their configurations up to about 70,000 feet. And the trick became then to develop an instrument that would allow you to measure the background no matter how you looked. And this was done with a radiometer system that was installed in the instrument bay of the U-2 aircraft looking up. And then all you have to do, in theory, is to fly the U-2 around and look in all directions in the sky and see if you get a slight anisotropy, if you will, or a slight difference in the background radiation, which then is the indicator of which way we're moving in space and how fast.
More than half a dozen flights were made, first in the Northern Hemisphere in 1978, and again early this year in the Southern Hemisphere. The experiments have shown both direction and velocity of the residual from that great explosion.
The results of this experiment will allow us then to precisely peg this without having to resort to more expensive satellite techniques. And I think the University of California at Berkeley group is to be commended for their ingenuity in doing this, and an exciting discovery, which I think for cosmologists is one of the most important things that's been done in the last several years in this area.
This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott speaking. For centuries, man has looked into the night sky, observed, studied, and wondered about what he saw, never knowing that what he couldn't see was an even greater mystery. The invisible force is seen through high-energy astronomy. That's the story Willard Scott reporting, details coming up. This is The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. A sounding rocket flight in 1962, launched by scientists searching for sun-produced X-rays reflected from the moon, accidentally found an intense flux of X-rays coming from the constellation Scorpius. Never seen before and totally unexpected, this was the beginning of X-ray astronomy. Subsequent rocket, balloon, and satellite flights have produced information on high-energy activities in space that go beyond our ability to explain with our current knowledge and laws of physics.
Quasars, pulsars, and black holes. These are the phenomena that are radiating the huge amount of energy in space that is being studied by the new science of high-energy astrophysics.
That's Richard Halpern, chief of the High-Energy Astrophysics Payload Section of NASA's headquarters in Washington, D.C.
The High-Energy Astronomy Observatory program consists of 3 coordinated satellites. The first satellite, containing X-ray detectors, was intended to perform an all-sky survey of X-ray sources. The second satellite, containing an X-ray telescope with associated detectors, was intended to study certain of the more interesting X-ray sources. And the third satellite, which is to be launched in September of 1979, contains gamma ray and cosmic ray experiments to perform a survey of the sky in those areas of scientific research.
HEAO-1, launched in August of 1977, discovered 1,200 new X-ray sources and possibly a large mass of hot gas in the universe surrounding the galaxies. HEAO-1, designed to operate for 6 months, fell from orbit early this year after more than 18 months of successful operation. HEAO-2, launched in November of 1978, is presently returning excellent data, which includes pictures of invisible X-ray sources.
HEAO-3 contains a different set of instruments to study gamma rays, which are the most energetic form of electromagnetic radiation, and cosmic rays, which are particles in space.
This experiment will look for atomic abundances in cosmic rays, which are clues to the age and makeup of galaxies. The second cosmic ray experiment will search for heavy radioactive nuclei in space.
The data from these satellites will take many years to analyze fully. However, it is possible on a relatively short time to understand what is being seen and to make a determination as to whether or not it is important and desirable to continue the kinds of studies that are being undertaken. Following the HEAO series, we fully expect to build on the knowledge gained by HEAO, and in fact we have currently 4 satellites in the very early planning stages. There are many studies going on in the high energy field. It is becoming increasingly evident that in order to understand space, we must study not only what we can see, but those phenomena that exist that we can't see.
This has been The Space Story, a weekly space and aeronautics report brought to you by this station and NASA, the National Aeronautics and Space Administration. Willard Scott speaking.